Good morning, folks. This is Mr. Oleson. Let's do some econ. We're in Unit 4 on imperfect competition. And today's topic is monopoly. Of the four different market structures, monopoly is the least competitive. So coming out of last unit where we analyzed perfect competition, now we're moving to the other side of the spectrum, looking at monopoly, which is a firm where there is only one large firm. So it's the least competitive of the structures. Examples of monopoly would be the electric company, like the PG&E here in the Bay Area, or something like De Beers Diamonds. In a monopoly, the firm is the market because there are no substitutes for that product the firm is selling. It is a unique product. You have no substitutes for it. So the firm is the market, and there's only one large firm. The barriers to entry are going to be very, very high. Firms are not going to be able to enter that industry. In fact, if the barriers to entry were any lower, then it wouldn't remain a monopoly because other firms would enter to compete with our monopolists. Okay? Monopolies are price makers. So as opposed to being price takers, like we saw in perfect competition, monopolies are going to be price makers. They're going to get to select the price they get to charge their customers. In fact, all three of the market structures in this unit, monopoly, oligopoly, and monopolistic competition, are all price makers. Sometimes monopolies advertise, sometimes they don't. That's not an especially unique characteristic of monopolies. Advertising becomes much more important later when we analyze monopolistic competition. So what are some examples of barriers to entry that may remain high and allow a monopoly to keep their monopolistic power? Okay. High fixed cost or really, really high startup costs create a high barrier to entry in certain market structures. A great example of this is in the electricity business. So there's only one electric company because they're the only ones that can make electricity at the lowest cost. In fact, this is something special. We'll talk about it a little bit later. It's called a natural monopoly. So this can prevent competitors from coming in. Even if you are really creative and you're able to raise a bunch of money, the startup costs for you to start your own electricity grid to generate your own power and the infrastructure needed to send that to customers all over the Bay Area would be so high it would prevent you from competing with PG&E. Geography or ownership of raw materials can create a barrier to entry to protect monopolies. An example of this would be De Beers Diamonds controlling all the diamond mines in the world allowed them to keep that monopoly. Legal barriers are a really interesting barrier to entry. And in fact, this is really important in the American system because the government and countries all over the world do this as well, issue patents. And the reason the governments would issue patents, which effectively creates a monopoly, is to protect inventors and allow them to earn profit back and forbid others from using their invention. So patents are really important in the pharmaceutical industry. It costs hundreds of billions of dollars to get a new drug to market. So the government allows them to set a patent on that so that they have 15 years or so, sometimes 10, sometimes 15, sometimes 20 years to earn back all that research and development money before competitors are allowed to start selling that particular drug as well. So in some instances, the government's actually creating a monopoly, which is a little bit counterintuitive. In fact, a lot of the things you're going to learn this unit related to monopolies are going to be counterintuitive. If you pause the video and analyze these 6 statements and then unpause it, you may be surprised to learn that all of these statements are false. All of these statements are false. This is sort of a myth-busting slide about monopolies. And by the end of today's lesson, you'll be able to see why all of these statements are false. Next topic is, can a monopoly be good for the economy? Okay, and the answer is definitely yes. And like I alluded to earlier, the electric company is a good example of this. If the electricity industry was more competitive and there were 3 electric companies competing for customers here in the Bay Area, they would have higher cost. And what having one electric company does is allow the PG&E to get their average total cost down as low as possible. In other words, PG&E can benefit from economies of scale more than a competitive electricity industry could. So economies of scale makes it really impractical to have a lot of smaller firms. And in this particular instance, we would call that a natural monopoly. And a natural monopoly means we're better off as a society to only have one firm produce because they're going to be able to get their average total cost down lower than anyone else. And a little bit later in class today, I'll show you how to spot that on the graph. Okay, let's move now towards the graph and talk about how we actually draw monopolies. What do you want first, the good news or the bad news? Well, first, let me share with you the good news. Okay, when it comes to drawing monopoly, the good news is there's only one graph. So if you think about what we did last unit, we had to do two graphs that were side-by-side graphs showing the market and then a representative firm. We don't have that situation in this unit because the market is the firm. So there's only one graph to draw. Another thing that's really helpful is the cost curves are all the same. So all the cost curves that you learned how to draw and interpret last unit are going to be exactly the same for the monopolies we draw today. Also, the most important rule in microeconomics still applies. If you're a monopoly, you're still going to choose to profit maximize at the quantity where marginal revenue equals marginal cost. Okay. And then other types of analysis still apply as well, such as the shutdown rule. So if you go to the MR equals MC quantity and that and find the price, if the price is below the AVC, then you're still going to shut down. As long as the price is above the AVC, then you're going to choose to operate as a firm. So all those things are going to be the same from last unit. And in fact, one part that's easier is you're only going to need to draw one graph. Okay, so what about the bad rule? Okay, what about the main difference? What about the bad news? Okay, the bad news is that monopolies have a downward sloping demand curve. So unlike a perfect competition where our old friend Mr. Darp came in at a straight horizontal line, monopolies are going to have a downward sloping demand curve. What does that mean? It means in order to sell more, they need to lower their price, and that changes marginal revenue. So the biggest difference that I'm going to show you in a minute is that marginal revenue does not equal price. In other words, I'm very, very sad to tell you that we must have a moment of silence for our friend Mr. Darp. Mr. Darp is going away this unit because price and demand no longer equal marginal revenue. Okay, so let's take a look at why that is. Take a look at this chart. Imagine we're looking at a monopolist. Maybe it's PG&E. Maybe they're deciding what price they want to charge for a kilowatt of electricity. Okay, let's go through an example of the demand for this firm, and let me show you why the marginal revenue is actually less than the demand. Okay, so if the price was at $11, the quantity demanded would be 0 because it's just too expensive. No one in that market is interested in paying, let's say, $11 for a kilowatt of electricity. They're just going to go to alternatives or they're going to move to a different place. So the total revenue is 0. So far, so good. So what is this firm going to do? They're going to lower the price. If they lower the price to 10, then the quantity demanded would be 1. So they're able to find one customer who's willing and able to pay $10, which was going to make their total revenue 10 and their marginal revenue 10. So far, so good. Nothing's different yet. However, take a look at this scenario. Because we're a price maker, we could lower the price again as monopolists. And in fact, if we lower the price again to $9, our quantity demanded is 2. Okay. 9 times 2 is going to give us a total revenue of 18, and the marginal revenue is just the change in total revenue. We went from 10 to 18, which is going to give us a marginal revenue of 8. Wait a second, what happened there? We charged $9 for that second unit, but our marginal revenue was only 8. What happened? Why is that? Well, we lost $1 from selling that first unit for $9. Okay, so in order to sell more units, we had to lower the price of all units, including that first unit that we could have sold for $10. So that's where our other dollar went. If you take a look at this visual over here, this first unit, which is kind of represented by this column here, we would have been able to get 10 for it. However, if we want to sell more, we had to lower the price of all units, including the units we could have sold at a higher price. So this first unit that we could have gotten $10 for, we only got 9 for. So we lost $1 there, which is why our marginal revenue is already less than our demand. And if we keep lowering the price, the same thing's going to happen. If we lower the price to 8, quantity demand is going to be 3. More people are going to be willing and able to purchase at $8. That's going to give us a total revenue of 24. But now look, our marginal revenue is only 6. Why is that? Take a look at the visual over here on the left-hand side. That first unit, which we ultimately could have sold for 10, now we're only getting $8 for. And even that second unit that we could have got $9 for, we have to only earn $8 from, because in order to sell more, we have to lower the price of all units, including the units we could have sold at a higher price. So if you keep going through this, what you would just see is the relationship between price and marginal revenue. As price goes down, marginal revenue decreases at a much faster rate. Okay. This is actually where our demand curve is, right? So the price and quantity combination is our demand curve. And then the marginal revenue curve is derived from that. And marginal revenue after the first quantity is going to be less than the demand. Okay, so what does that mean? Marginal revenue is always less than the demand. This is going to matter when we choose our profit maximizing quantities, when we analyze our monopolies, and it's going to have some consequences. Okay, let's take a look at this scenario where we look at our demand curves, our marginal revenue curves, and then our total revenue curves. What we just derived from that last slide is a downward sloping demand curve and then a steeper marginal revenue curve. And I'll talk about it a little bit more in class. This is known as the monopoly gang sign. We have a downward sloping demand curve and then a steeper marginal revenue curve. Okay. So if you plotted those numbers out, you would get something like this. Okay. If you were also to compare that with the total revenue of different quantities, then you'd get a curve that looks like this. And it's really important that you understand that when marginal revenue hits 0, our total revenue is going to peak, right? So in this instance, that looks like it's at a quantity of 8. So when the marginal revenue curve crosses the axis at a quantity of 8, then the total revenue for that firm is going to peak. And then if you kept producing your 9th, 10th, 11th unit, which you could, right? And you could, in fact, you could earn prices up here along the demand curve at those quantities, your total revenue would actually be falling. So what does this tell us? Okay, it allows us to analyze the elasticity ranges of that particular demand curve. Okay, so if we use the total revenue test, we can see that for this first segment of prices on the demand curve between quantities of 1 and 8, it's an elastic demand curve range. Why? Well, we can use the total revenue test. The price goes down and the total revenue goes up. And if that relationship is inverse, we know by definition that it's an elastic range of the demand curve. Look, as we move, say from 1 to 2 units or from 3 to 4 units or from 5 to 6 units, what's happening? Price is falling. How do I know? Because my demand curve tells me the price. So as we move from 3 to 4 units, say, for example, we can see that the price is going down. And as the price is going down, what's happening to total revenue? Our total revenue is going up. How do I know? This curve tells me so. And why is this curve going up? Because the marginal revenue curve is greater than 0. So price goes down, total revenue goes up. It's the elastic range of the demand curve. Once MR crosses 0, then we enter the inelastic range of the demand curve. Why is that? Because now the price is going down and the total revenue is going down. Price goes down, total revenue goes down. By definition, that is an inelastic range of the demand curve. Okay, so this is the inelastic range of the curve. This is the elastic range of the curve. The turning point is at the point where MR equals 0. And then in fact, right here in the middle is when it would be unit elastic, right? So this is the elastic range of the demand curve where the price elasticity of demand would be something really high, greater than 1. At some point, it's going to hit 1, where the percent change in quantity equals the percent change in price. And then over here, it's going to have a price elasticity of demand that's less than 1. Okay, so those are the elastic and inelastic ranges of the demand curve. Those will come up a little bit later in some FRQs. The takeaway from this is that monopolies are only going to choose to produce when they're in the elastic range of their demand curve. Why? Because that's when total revenue is going to increase. They're never going to choose to operate out here in this inelastic range because at prices that are that low, because they would never choose to do that because their revenue would be lower, right? So why would a firm choose to produce in a range where their total revenue is falling, right? They're always going to want to be in this green range where they have an elastic range to the demand curve, because price drops are going to result in a total revenue increase. All right, let's move into profit maximization. So how do we put these curves together to make some decisions as a monopolist? Take a look at this scenario. We have our downward sloping demand curve and our steeper marginal revenue curve for the reasons we've already explained. And then we have our existing cost curves. Don't get overwhelmed by this. It's the same exact cost curves that perfectly competitive firms face. Our marginal cost curve goes down and then comes back up. Our ATC drops, hits a minimum when it crosses the MC and then comes back up. And now we've just thrown our monopoly gang sign, demand and marginal revenue curve, on top of those same existing cost curves, okay? So what output should this firm produce? This firm should produce at the quantity that all profit maximizing firms choose to produce at, which is where MR equals MC. So looking at the graph, you find the MR equals MC intercept, which is right here, which is at a total quantity of 6, okay, which tells us in order to profit maximize, this particular firm should produce 6. So the next question is going to be, how do we get our total revenue, our total cost, and then therefore our profit or our loss for this firm, okay? A common mistake is students see this intercept right here and they say, okay, well, the quantity is 6 and the price is 5 because this intercept happens at about 5. That's not the case. Because we're a monopolist, we get to charge more. We get to go charge a higher price. Which curve gives us the price that we're able to charge? It's the demand curve. So we find the profit maximizing quantity where MRM equals MC, and then we go up, straight up to the demand curve at that quantity to find the price that we're able to charge, which in this case is 7. So again, really important. You find the MR equals MC quantity, but that does not give you the price. You go up to the demand curve to give you the price, which in this case would be 7. So 7 times 6 would give us a total revenue of $42 in order to maximize our profit. Next, we want to find our total cost. We stay at our MC equals MC quantity. All the intercepts we're looking for, once we've found that quantity, are going to be up, straight up or down from there. We're going to go down now to the ATC at the profit maximizing quantity of 6 to get a total revenue of to get total cost of about 36. And then that profit is going to be the difference between those two, which is going to be a profit of, in this case, of about $6. Okay, so that, ladies and gentlemen, is a monopoly earning a profit. Pretty cool. Pretty cool that you guys understand how this works now. You may recall on day 1, I do the lesson about can you see the cow, and I show you a really crazy graph, and no one's able to understand it yet. But now you guys can see this cow because you have all the knowledge and skills needed that have gotten to this point in the class. So pretty cool. Oh, and then so what's the conclusion of what we just did? A monopolist produces where MR equals MC, but charges the charges the consumer a higher price as identified by the demand curve. Okay, so that was through the skills that we just went through. Okay. What if the costs are higher? So take a look at this scenario. The difference now is we have a higher ATC. So this is a higher cost industry. We've also added an AVC on here. If you, just like last unit, if you're drawing this graph on your own, you would not need to draw the AVC. However, in this instance, we've been given it. So we're going to use it as part of our analysis. If you see an AVC, the item you always want to consider is the shutdown rule. Okay, you want to make sure the shutdown rule doesn't apply. So what are we going to do in this instance? We're going to follow all the same steps. We're going to find the profit maximizing quantity where MR equals MC. We're going to go up to the demand curve to find the price that we get to charge. Then we're going to go up again to the ATC to find the cost that we have to pay. And then we would do total cost minus total revenue to get this area in red here, which is the loss that we're operating on. Why? It's because the cost curve is higher than the demand curve, which gives us our revenue. Okay, we're still going to choose to operate, however, because our fixed costs would be greater than this operating loss. How do I know? Well, my fixed cost at this quantity would be our ATC minus our AVC times the quantity. So this firm should choose to stay open and loss minimize at a quantity of 10 where they can charge a price of 9. A little bit tricky because our MR equals MC intercept is below the ABC, but the price isn't, but not below the ABC because the demand curve gives us our price. So the answer for this one is operate at a loss of $10, do not shut down. Okay, let's do some practice. Go ahead and pause the video at this point and see if you can answer all these questions on your own. All right, first step for all firms is to find the profit maximizing quantity where MR equals MC, which in this instance is 5. We find the MR equals MC quantity, and then we go up to the demand curve to give us the price. Price is 10, quantity is 5, so the total revenue is 50. At the quantity where MR equals MC, we go down to the ATC curve to get our total cost of about 25, not drawn to scale, that at a quantity of 5, the ATC is roughly 5, so we call it a total cost of 25, which is going to give us a profit of $25, which is going to give us a profit per unit of $5. Why? Well, we have a total profit of 25 divided by 5 units is going to give us $5 per unit of profit. Here's another monopoly. This one is like a constant cost monopoly. Sometimes you'll get monopolies that look like this where the law of diminishing marginal returns is actually not applying to them. All the same skills apply. Don't get overwhelmed with, you see this. Just use all the same skills we've been building to find the profit maximizing quantity and the area of profit or loss. This is an example of where it's a constant cost industry effectively, and diminishing marginal returns is not kicking in yet. So what do we have here? Well, we're going to find our profit maximizing quantity where MR equals MC. So pause the video, try to get these answers on your own. And welcome back. Our profit maximizing quantity is right here at 6. Once we find the quantity, we go up to the demand curve to find our price and total revenue, which in this instance is 54. Then we go down to our ATC and over to find a total cost of 36, which is going to give us a profit of $18. And 6 units for a total profit of $18 is going to give us a profit of $3 per unit. All right, folks, here is a multiple choice question pulled from an AP exam to give you some more practice on this. So go ahead and pause the video and choose your best answer. Question says, if a firm produces 10 units of output, what will its economic profits be equal to? It's going to choose, it's at 10 units, which also happens to be where MR equals MC. Once we're at that quantity, what price are we going to choose to charge? Well, the demand curve tells us so. If we want to sell 10 units, what price could we charge? The demand curve tells us. So what do? We go up to the demand curve at 20. Then we would come down to the ATC at 15, and we would get an answer of $50 economic profit. What's the accounting profit? I don't know. I'm not an accountant. I'm an economist. But I could tell you that if we include their implicit cost, they're going to earn $50 in economic profits. And then one more practice MC here. Which of the following most likely occur if the firm produces beyond 10 units? Go ahead and pause the video, find the best answer choice. Correct answer is C, as in cat. The firm would have to lower its price to sell more than 10 units. Why is that? The demand curve tells us so. Okay, so if we wanted to move out here and sell more than 10 units, say 11 or 12, what would we have to do? Lower the price. How do I know? Because the demand curve tells me the willingness and ability of consumers to pay for that product. Here's a cool excerpt from Krugman on the price making ability of electricity of firms, and it talks a little bit about price elasticity of demand and how that impacts to what extent firms, monopolists, can actually price make. So pretty cool point of interest I'd recommend you check out in Krugman. Okay, wonderful humans. One more topic we need to cover in this, which is to what extent are monopolies efficient? Before we do that, I'll leave you a quick Easter egg once again. Bonus participation points today for folks who come back and use alliterations for the rest of class. So if you speak using an alliteration, then we'll have a fun little inside joke, and then we'll also be able to give you some bonus participation points. Let's address efficiency. Okay. Are monopolies efficient? Absolutely not. Monopolies are inefficient market structures for a couple different reasons. They charge too high of a price and they don't produce enough. These buzzwords are going to come up a lot as you do explain points on FRQs in this unit. Monopolists charge a higher price and produce too low of a quantity at too high of cost to be efficient. What do we mean by that? Monopolies are neither allocatively efficient nor productively efficient. Let me show you why that is using the graph. Take a look at this scenario, imagining that this market is actually perfectly competitive to start. So looking at this graph, we can say this is a perfectly competitive market where we have a supply curve and a demand curve. And like we've already established, the supply curve is just the sum of all the marginal cost curves of all the firms in that particular market. And that would give us an equilibrium price, PC, price for perfect competition, and quantity, PC, quantity for perfect competition. Okay, and as you already know, this would give us a consumer surplus and producer surplus that would be maximized in those two areas. I want you to take a mental screenshot of that CS and PS, and I want you to compare that with what would occur for a monopolist. Well, if this perfectly competitive market became a monopoly, what would happen? Well, the marginal revenue curve would be lower than the demand curve, right? So we're going to assume the marginal cost curve is the same. However, we're going to throw the monopoly gang sign on there, and we're going to say, well, if this was a monopolist who was setting the price, their marginal revenue would fall at a steeper rate than their demand curve. What would that do? Well, now profit maximizing firms would choose to produce where MR equals MC. Then they would go, so they would choose a quantity M, which is clearly lower than the perfect competition quantity, and they would charge a higher price up here at PM, which is a higher price than the perfectly competitive price. So just by right there, by throwing the marginal revenue curve on there, you can see that monopolists charge a higher price than in perfectly competitive industries and choose to produce a lower quantity than perfectly competitive industries. Okay. What about consumer and producer surplus for monopolies? Okay, well, this would be the pricing quantity. Monopolists would choose to produce that. Where's our consumer surplus? Well, it's simply the difference between what consumers are willing and able to pay and what they actually pay. So we have a smaller consumer surplus triangle there. The producer surplus is the difference between what producers are willing and able to charge and what they actually earn. So our producer surplus would look something like this. We have an area that was formerly PS and CS, and now it is BS, ladies and gentlemen. That's right. We have our old enemy from the last unit occurring here. We have some dead weight loss. The dead weight loss is the area that was formerly producer and consumer surplus that is now gone because the monopolist is choosing to underproduce and choosing to charge a higher price. So we can see that monopolies are inefficient because just by the fact that they exist, we're going to have some dead weight loss occur. Okay, pretty interesting to compare to competitive industries last unit, where the only time we had dead weight loss is if something funky was going on in that market, or we had an intervention in the market that we didn't like. In this instance, just by the fact that it's monopoly existing is going to create some dead weight loss. Okay. All right. Now, what about the idea of productively efficient? Are monopolies productively efficient? In other words, does the price equal the minimum ATC? And the answer is no. Okay. Why is that? Where our MR equals MC quantity is in this instance is at a point on the ATC. So if we go to that quantity and we go up to the ATC, it's not at the minimum ATC. Okay, we're choosing to produce where our average total costs are higher than at the minimum point. So, but therefore, monopolies are not productively efficient. Neither are monopolies allocatively efficient. You'll recall from last unit, or in order to be allocatively efficient, you need to produce what price equals the marginal cost. Where does price equal the marginal cost on this graph? It would be right out here. It looks like about either 7 or 8 units. The marginal cost curve is here. The demand curve gives us all the prices. So price equals marginal cost right there, okay? And that's not the case for us, because at our profit maximizing quantity, the price is greater than the marginal cost. The price is up here and the marginal cost is down here. So there's a gap between the price and the marginal cost at the quantity we're producing. So we are not allocatively efficient either. All right, so that's addressing efficiency and monopolies. Last graph you need to be able to spot is a natural monopoly. So we've already talked about the concept of a natural monopoly. What I'm going to show you now is how you actually spot that on the graph. What you're looking at right now is a graph of a natural monopoly. How can you spot it? At the socially optimum quantity, the average total cost curve is still falling. It's actually better to have one firm because the average total cost is still falling at the socially optimum quantity. How do we know that? What's the social optimum quantity? It's where price equals the marginal cost. Price is given to us by the demand curve. So if you go to the socially optimum quantity where price equals marginal cost and you find the average total cost curve, the average total cost curve is still falling at that rate. What does that tell us? That tells us that this was a perfectly competitive market, and we were getting exactly the right price and quantity that society wanted. Then we would still be at a higher ATC than we would want to be, right? In other words, that firm would still be benefiting from economies of scale, even at the socially optimum price, okay? So what does that mean? That means that we want this particular monopolist to have as many competitors as possible, and them losing customers would actually make us worse off and make us be operating at an even higher point on the ATC. This monopoly should look funky to you because the cost curves are so slow, are so flat, right? So that's what looks different about national monopolies. The rate at which the MC is rising and the rate at which the ATC is dropping are really flat and at high quantities, which is going to create this scenario where at the social optimum quantity, ATC is still falling. This looks different than the more normal monopolies we've been drawing for most of the presentation today. And you can see that this is not a natural monopoly, because if you go to the socially optimum quantity, which is found here, you could see that at the socially optimal quantity, the ATC is now rising, right? So this is not a natural monopoly. They're no longer benefiting from a falling ATC at that quantity. So this is not a natural monopoly, and it's not something we want to protect and regulate in the same way as we would with this one. All right, thank you so much for paying attention. You guys are awesome, and I'll see you back in class.